When you look at a massive suspension bridge, what you notice first is the grand design.
Right, the macro level.
Exactly. You see the sweeping cables, the towering pillars, the way the whole structure just sort of spans the water. But you don't really see the thousands of individual mathematically perfect bolts holding that entire thing together.
And if even one of those bolts is threaded incorrectly or made of the wrong alloy, the structural integrity of the entire bridge is completely compromised. We admire the macro, but we really rely entirely on the micro.
Yeah, and when you step into the world of language, specifically, the formal high-stakes communication, it is exactly the same. Okay, let's unpack this. Welcome to today's deep dive.
Glad to be here.
Our mission today is to really uncover the rigorous technical logic behind the English language. And to do that, we're using a very specific stress test as our guide. We are looking at Section 1 of the IBPS PO Prelims Model Paper 05.
And if we connect this to the bigger picture, you might be wondering why a competitive Indian banking exam matters to you. The reality is, the linguistic traps designed for this paper, they're the exact same mechanics used in global corporate communication, complex legal contracts, and, everyday media manipulation.
Right.
They evaluate how you process information, identify inconsistencies, and apply rigorous frameworks under intense pressure. It's totally fine to find this challenging at first.
Well, we are going sequentially through 30 distinct challenges, looking at how grammar, syntax, and vocabulary all work together. So let's start with the traps of context. We're jumping right into question 1, which begins with a macro-level reading comprehension passage about the shift to electric vehicles, or EVs, in India.
Yes, the big picture.
Right. And question 1 literally asks why 2- and 3-wheelers are leading the shift to EVs. If I'm taking this test, my instinct is just to skim for facts.
And that skimming strategy works for surface-level fact retrieval, which is the core concept being evaluated here.
So I just look for the answer in the text.
Exactly. Option E points to lower running costs. That is the correct choice, because the text explicitly states this. It's a direct, literal match.
Okay, which perfectly sets up question 2. This one asks, what makes EVs viable, according to the passage?
And the evaluative concept here is identifying compound causes within a text.
Ah, compound causes.
Right. The correct choice is B, which identifies falling battery prices and the FAME scheme. The technical rationale is that you have to find the specific dual catalysts mentioned by the author.
Yeah, and it's so easy to bring in outside bias there. I might know about other government initiatives, but I have to ignore them.
You must turn off your outside bias. The strict rule of these evaluations is absolute textual confinement.
That is such a crucial mindset shift. You aren't being asked what's true in the world, you're being asked what's true in the text. Which brings us to question 3. This asks about the actual roadblocks for EVs in the passage.
This tests your ability to locate contrasting information. Option D is correct because it identifies that public charging stations remain sparse outside big cities.
And question 4 is another roadblock challenge. It asks why buyers are unsure about long-term value.
And option C is correct here. The passage explicitly links buyer hesitation to the fact that the resale market is young. The technical rationale is simply mapping the cause to the effect as defined strictly by the author.
Makes sense. But question 5 is where it gets a bit sneaky, I think. It asks you to identify a true statement from a list, and option E says that some housing societies hesitate to allow chargers.
Yes, this evaluates what I call the negative qualifier test.
The negative qualifier test.
Exactly. When candidates speed read, they look for keywords. The exam checks if you caught the specific friction point attached to those keywords. The passage states that housing societies hesitate to allow chargers.
So they don't outright ban them, they just hesitate.
Right. And the distractor options directly reverse the passage's facts, for instance, claiming EV registrations are falling when the text actually says they are surging. You have to validate option E as definitively correct by eliminating the full statements.
Wow, you really have to read closely. Okay, let's look at how they test vocabulary in context. Question 6 asks for a synonym for the word surged. Without a dictionary, how do you logically deduce that? I see options like soared, dipped, and stalled.
Think about the directional momentum of language. That's the verbal concept here. Surged implies a sharp, upward, and rapid movement.
Like a wave.
Exactly. Option B, soared, shares that exact upward vector. It neutralizes dipped or stalled, which convey the opposite movement or, a lack of movement entirely.
That makes total sense. And question 7 does the exact same thing. The text says the models became viable and we need a synonym.
Precisely. Viable means practical or workable. Option D, feasible, is the correct choice because both words carry the semantic weight of something being fundamentally successful.
Okay, but question 8 completely flips the script. The text mentions charging stations are sparse, and you need to find the antonym, the opposite meaning.
Yes, and this is a classic psychological trap.
Because under pressure, I just want to find a word that relates to sparse, like rare or thin.
And that is exactly what the test makers are banking on. Rare, thin, scanty. They're all provided as options. Under time pressure, a candidate's brain naturally seeks a synonym. It evaluates your psychological discipline. You have to force yourself to reverse the search and find option C, abundant.
Wow, that's incredibly clever. All right, so we've looked at how whole paragraphs can trick you. Let's move to section 2 and zoom in a bit. This is the cloze test. It takes a continuous passage. This one is about the critical importance of sleep, and it removes key anchoring words. Question 9 is the first blank. It says, doctors repeatedly blank that adults need 7 to 8 hours of sleep. My choices include stress, deny, joke, and complain.
Here we apply semantic analysis. Doctors are presented in the text as providing vital medical authority.
But choosing joke would just be weird.
Exactly. To choose deny or joke would illogically undermine the entire premise of the text. Option A, stress in this context, meaning to emphasize, is the only syntactically and logically sound choice.
Got it. Moving to question 10, the next sentence says, yet many professionals blank on far less. The options include things like arrive on or manage on. I know what it means conceptually. They survive on less sleep.
This evaluates your knowledge of phrasal verb logic. Option E, manage on, is definitively correct. It's a recognized construction, meaning to get by with a limited amount of a resource. Native speakers use these intuitively, but the test forces you to recognize why arrive on makes absolutely no semantic sense here.
It's all about the mechanics. Question 11 gives us the phrase, poor sleep, blank your mood. The options are words like sharpens, restores, and damages.
And the concept is contextual alignment. The sentence describes a negative consequence of poor sleep.
So we need a negative verb.
Exactly. Option C, damages, is structurally required over positive verbs like sharpens.
Which perfectly explains question 12. Experts want people to blank rest.
Right. Option B, value. You wouldn't discard a biological necessity. Value aligns perfectly with medical advice.
Okay. Question 13 is the final blank in this section, and I find this one fascinating. The passage concludes, small changes can bring a blank improvement. The options are invisible, doubtful, bitter, marked, and backward.
This is a perfect example of what linguists call semantic prosody.
Semantic prosody.
Yes. Words inherently carry a positive, negative, or neutral charge, almost like electricity. The sentence is establishing a positive resolution. Small changes lead to a beneficial outcome.
So the word modifying improvement has to be positive.
Correct. Option D, marked, meaning noticeable or evident, carries the correct positive charge. Words like invisible or doubtful possess a negative semantic prosody. They fundamentally clash with the sentence's trajectory.
It's like playing a sad minor chord at the end of a really upbeat pop song. It just feels wrong.
That is a highly accurate analogy.
Okay, we know how to fill in the blanks, but how do we stitch complete, independent sentences together into a coherent story? This brings us to section 3, the parajumbles. We have 5 completely out-of-order sentences detailing the history of millets, labeled A through E. Question 14 asks us to identify the first sentence.
Parajumbles require you to construct a logical narrative architecture from chaos. You cannot just guess.
So I approach this like directing a movie. We have 5 scenes. The first one has to establish the baseline, the status quo.
Exactly. And sentence D, which states, millets once formed the staple diet in many Indian homes, provides that historical baseline. So D is the correct choice for the first sentence.
Right. Question 15 asks for the second sentence. A story needs a conflict, right?
It does. Sentence B introduces the narrative conflict. Cheap rice and wheat later pushed them off the plate. The status quo has now been dismantled. B is correct.
I'm going to skip slightly to question 16, which asks for the final sentence. How do we mathematically prove which sentence is the grand finale?
You look for mechanical clues. Sentence C says, farmers thus see a fresh chance in this hardy crop. The word thus is a conclusive conjunction.
Oh, wow. It's a literal signpost.
Yes, it acts as the final resolution, making C definitively the last sentence.
That leaves question 17, which asks for the sentence that comes after sentence E. Sentence E says, nutritionists now praise Millis for fiber and minerals.
And the logical result of that praise the cause and effect is sentence A. Demand is rising again in cities and restaurants. So A is the correct choice here. Cause and effect neutralize any ambiguity.
Act 1 to resolution. It is incredibly satisfying when the logic just clicks into place like that. But now we have to leave the high-level storytelling behind. Section 4 is the micromechanics, grammar, and error spotting. We've built the house, and now we are inspecting the individual bolts.
This is where intuition often fails. It's very common to struggle here because conversational English is full of accepted errors. We have to rely on rigorous theoretical frameworks.
Which is so interesting because we violate these rules in casual conversation all the time. Let's look at question 18. No sooner had the chief guest arrived than the audience stands up to greet him. Honestly, in a fast-paced story, someone might naturally say that.
They might, but it evaluates strict tense agreement. The primary clause is established in the past. Perfect had arrived.
Right.
Therefore, the subsequent action must also exist in the past timeline. Stands as present tense. Option D correctly identifies this error. It must be corrected to stood to maintain chronological consistency. You cannot time travel halfway through a sentence.
No time traveling, got it. What about question 19? Ram, Shyam, and me went to the market. I hear this mistake literally every day.
It's very common. This evaluates subject versus object pronouns. The phrase Ram, Shyam, and I acts collectively as the subject performing the verb went.
So they are doing the action.
Exactly. Therefore, you must use the nominative pronoun I. Option A contains the error. The addition of Ram and Shyam distracts the brain, making me sound acceptable to the ear, but the underlying mechanics forbid it.
So it's like throwing a ball. If you're throwing the ball, you're the subject. You use I. If you're catching the ball, you use me. You wouldn't say me threw the ball.
That's a perfect way to visualize it.
Okay, question 20. Had I known about the traffic, I would have started an hour earlier for the airport. Where is the error?
There isn't one. Option E, no error, is the correct choice.
Wait, really? A trick question.
It evaluates the third conditional, expressing a hypothetical past situation and its hypothetical past result. The strict structural requirement is had, plus the subject, plus the past participle, followed by would have, plus the past participle. It is flawless. Test makers include flawless sentences to test your conviction.
That's brilliant. Okay, question 21 is one I just have to laugh at. This book is more better than the one you lent me last week. People really do say more better.
They do, but grammatically, it violates the redundancy rule. Option B is correct in identifying the error. Better is already the comparative form of good.
So adding more is basically doubling up.
Exactly. It creates an invalid double comparative. It's like wearing two pairs of glasses at the same time to see better. The more simply must be dropped.
Okay, let's talk about prepositions, because question 22 trips up so many people. The sentence says the manager distributed the sweets among the two clerks. What is the technical issue here?
This requires a highly specific rule regarding prepositions of number. When dividing or sharing between exactly two distinct entities, the preposition between is mandated.
And among is for larger groups.
Yes. Among is strictly reserved for a collective of 3 or more entities. Because the text explicitly specifies two clerks, it must be between. So option C contains the error.
Moving to phrase replacement, question 23. The committee will discuss about the proposal tomorrow. The test says choice A is correct, meaning we need to drop the word about. Why?
Because discuss is a transitive verb. Transitive verbs transfer their action directly to an object without needing a prepositional bridge. You just discuss the proposal.
So a transitive verb is like taking a direct flight. You don't need a layover, you just go straight to your destination.
I like that, yes. Adding about is a very common syntactical intrusion from regional dialects, but it is technically incorrect in standard formal English.
Which perfectly explains question 24. It asks us to correct the phrase cope up with.
Exactly. This is idiom correction. Option A, cope with, is correct. Cope with is the standard rigid idiom. The word up is a phantom word that simply does not belong.
We have one last piece of grammar mechanics in this section. Question 25. He has come to Delhi in 2019 and has lived here since. The test says option D is correct, replacing has come with the simple past tense came. Why is has come wrong if he still lives there?
Let's provide a robust evaluative framework for this. The sentence contains a stated specific time in the past of the year 2019. When an action is completely finished at a specific past time, it mandates the use of the simple past tense. The present perfect has come cannot sit alongside a specifically stated past timestamp.
Because the timestamp neutralizes it.
Precisely. The simple past came neutralizes the grammatical ambiguity.
That is such a clean rule to remember. If there's a timestamp, use the simple past. All right, we have survived the micromechanics. We are on the final stretch of the gauntlet. Section 5, the final Polish. This covers fillers, spelling, and vocab. Question 26 is a double filler. The court blanked the verdict after hearing arguments from blank sides.
What's fascinating here is that these final questions evaluate a candidate's speed in pattern recognition. For question 26, the concept is procedural logic. Option E is correct. The court delivered the verdict after hearing both sides.
Because fairness dictates they listen to everyone.
Right. Distractor options might suggest delaying the verdict after hearing no sides, which breaks the fundamental concept of judicial reality.
The same causal alignment is tested in question 27. The startup blank rapidly because investors were blank by its growth.
Yes. Option C is correct. Expanded and impressed. You wouldn't expand because investors were bored. The cause and effect have to logically support each other.
Makes total sense. Question 28 tests historical contrast. Vaccination drives blank millions of children against diseases that once blank entire villages.
Option B is the correct choice here, protect and ravaged. Vaccinations perform a protective function today against a destructive force from the past. Ravaged perfectly captures that historical devastation.
Okay, question 29, spelling. I am terrible at this without autocorrect. The test asks you to find the incorrectly spelled word among believe, achieve, deceive, perceive, and receive.
Option B is correct because receive, spelled on the test as R-E-C-I-E-V-E, is fundamentally incorrect.
It violates the old rule, right?
Yes, the age-old mnemonic, I before E, except after C. Since the letters follow a C, the E must come first, R-E-C-E-I-V-E.
Finally, question 30. Synonym identification. The word is abandon. We have options like adopt, protect, continue, and forsake.
To abandon is to leave completely. Option D, forsake, is the exact synonymous match. What is notable in the test design is that adopt, protect, and continue all express the complete opposite intention.
They denote taking responsibility.
Exactly. The test gives you 3 antonyms to deliberately confuse your rapid recall under pressure.
And just like that, we have successfully navigated the entire question sequence. We started at the macro level themes, looking at how reading comprehension traps us with negative qualifiers. We zoomed into the continuity of paragraphs with semantic prosody, and then we went all the way down into the micromechanics of transitive verbs, tense agreements, and spelling rules.
It truly highlights the incredible rigid architecture required to master standard English for these high-stakes evaluations. Every single word functions as a load-bearing pillar.
But as we wrap up this linguistic masterclass, we have to acknowledge the elephant in the room regarding how we actually use language every day. I mean, we just spent this entire deep dive treating English like it's a frozen, unchangeable mathematical equation.
And this raises an important question that I want to leave you to mull over. Standardized tests freeze language in time to check its anatomy based on strict historical rules, which is completely necessary for a standardized evaluation.
Right, of course.
But language in the real world isn't frozen. It is a living, breathing organism. Think about your modern digital communication, texting, slang, emojis. We drop vowels, we ignore capitalization, we shatter tense agreements, and we completely bypass the rule of I before E except after C.
Oh, the time.
We break almost every single rule we discuss today on a daily basis, and yet the communication is highly effective. We perfectly understand each other. So does strict formal grammar actually create clarity? Or does it just enforce uniformity?
That is brilliant. It's definitely something to think about the next time you send a grammatically atrocious text message that your friend understands perfectly. Thank you so much for joining us on this deep dive today. Keep learning, keep exploring, and most importantly, keep questioning the structures around you. Until next time.
Today, we are hacking the quantitative aptitude section of a major standardized test. We aren't just going, to solve problems. We're actually going to reverse engineer the exam so you can see the traps long before you step in them.
Exactly. It's about getting ahead of the test makers.
Right. And when you first stare at a standardized test paper, specifically the math section, it can feel like looking at a dense, impenetrable forest. You just see this massive wall of numbers, charts, equations.
Oh, absolutely. It's a very common reaction. It feels incredibly binary, like you either see the path immediately or you are just staring at a bunch of terrifying trees.
Yeah, you feel like you need a map in your head already, or you're just going to get completely lost.
But that fear, that's exactly what the test makers are banking on. If we pull back the curtain, quantitative aptitude isn't about being some innate mathematical genius. It really isn't.
Thank goodness for that.
Right. It is entirely about spotting patterns, maintaining your composure, and, well, just following logical steps. It's a learned skill, and honestly, more importantly, it's a predictable one.
And that is exactly why we are here today, to build that confidence for you. Think of us as your study guides.
We're here to clear the path.
Exactly. So our mission for this deep dive is to tackle Section 2 of the IBPS CRP PUMT 2026 Preliminary Examination Model Paper 05. We are going to cover questions 31 through 65 sequentially.
Every single one. We aren't skipping anything.
Right. But we're not just going to read you a list of equations. We are going to look at the archetypes of these questions and the psychological tricks you need to beat them. By the end of this, you're going to have a rock-solid, unfragmented foundation.
That's the goal. Let's get into it.
Yeah, let's unpack this. We start with data interpretation, which is questions 31 through 40.
And this is where a lot of people just freeze up because they get hit with a massive influx of information all at once.
Right, like the first 5 questions, 31 to 35, they're based on this data table detailing the populations of 5 different villages. I always like to think of a data table as an organized pantry.
Oh, an organized pantry. I like that.
Yeah, because you don't walk into a pantry and try to memorize every single can of beans, right?
Yeah.
You just grab the ingredients you need for the recipe you're cooking right now.
I love that analogy. You don't need to invent anything. You just need to extract it. The trap here isn't the arithmetic. It's the extraction.
Right.
The table gives us total population, male percentage, and literacy rate for villages P, Q, R, S, and T. That's it.
So when question 31 asks for the number of males in village R, we don't look at the whole pantry. We just go directly to the R shelf.
Exactly. You just grab what you need.
The population there is 3,500 and 60% are male. But even here, doing long multiplication on scratch paper is a trap, isn't it?
Oh, massive trap.
Yeah.
Don't multiply 3,500 by 0.6 on your paper.
Yeah.
Chunk it. I mean, 50% is half, right? So that's 1,750.
Okay.
And then 10% is just dropping a zero, so 350. Add 1,750 and 350 in your head, and you get 2,100. You save crucial seconds.
Wow. And that same extraction logic applies to the rest of the table. So for question 32, it asks for females in village S, but the table only gives the male percentage at 45%.
Right, so you just take the inverse.
Yeah, the inverse means 55% are female out of 6,000, which chunks out cleanly to 3,300.
Super clean.
And question 33 asks for a ratio of literates in P to T. So you pull 70% of 4,000, which is 2,800, and 60% of 4,500, which is 2,700. The ratio is just 28 to 27.
Notice how the test makers design the numbers to collapse cleanly, They aren't trying to punish you with messy fractions here.
That's reassuring. Even question 34, asking for the average population across all 5 villages, is just adding them up to 23,000 and dividing by 5 to get 4,600.
Exactly. And question 35 is just another inverse trick. It asks for the illiterate population of Q when the table gives a 64% literacy rate.
So you just find the remaining 36%.
Exactly. 36% of 5,000, which gives you 1,800.
Okay, so the pantry is definitely manageable. But let's look at questions 36 through 40. This is a caselet. It's this paragraph of text explaining that 800 students play cricket, football, or hockey.
The dreaded wall of text.
Yeah, I have to admit, when I see a wall of text instead of a nice, neat grid, my instinct is to read it top to bottom like a story. Why is that a bad idea?
Because it's not a story, it's a disguised spreadsheet. If you read it like a novel, your working memory just gets totally overloaded.
So what's the move?
The trick is to translate those sentences into hard numbers the second your eyes hit them. Just map it out immediately.
Okay, let's try it. So sentence 1 says 800 total students. Sentence 2 says 45% play cricket.
Stop right there and calculate.
Right now.
Right now, 45% of 800, half is 400, minus 5%, which is 40, gives us 360 cricket players. Write that down immediately.
Okay, got it. Then it says the number playing football is 5/9 of the cricket players.
Again, stop and calculate. 5/9 of our new number, 360.
So divide 360 by 9 to get 40, multiply by 5, and we have 200 football players.
Perfect.
And the final sentence says the remaining students play hockey. which is just the 800 total minus the 360 cricket and 200 football players, leaving 240 for hockey.
See, so before we even read question 36, we've already built our own pantry.
Oh, wow. That makes it so much less intimidating. And once you do that, the questions are instantly solvable.
They really are.
Question 36 asks how many play hockey. We already know it's 240. Question 37 asks the difference between cricket and football. Well, 360 minus 200 is 160.
Yep. And question 38 wants football players as a percentage of the total. 200 out of 800 is 1/4 or 25%.
Simple. Question 39 asks for the ratio of cricket to hockey, which is 360 to 240, simplifying cleanly to 3 to 2.
Right. And then question 40 throws a slight curveball and asks, what if 40 hockey players switch to football? What's the new ratio?
Oh, so you just adjust the buckets you already made. Hockey drops by 40 down to 200. Football gains 40 up to 240.
Exactly. So the new ratio of football to hockey is 240 to 200, which simplifies to 6 to 5. By translating the text instantly, you completely remove the panic.
That makes so much sense. Okay, so we figured out how to extract hidden numbers from tables and paragraphs. But what happens when the numbers are stripped of their real-world context entirely?
Pure algebra.
Yeah. That brings us to questions 41 through 45, which are pure algebraic quadratic equations. You have to find the roots for an x equation and a y equation and then compare them.
This is a section where students lose massive amounts of time factoring equations when they don't always need to.
Right. Before we jump into calculating, I want to ask about a specific trick here. Can you just guess the relationship based on the plus and minus signs in the equation?
You mean without solving it?
Yeah, I always think of it like reading the weather before a storm to know if you even need an umbrella.
Reading the weather is a brilliant way to put it. And yes, paying attention to the signs is a massive time-saving mechanism. You really don't always have to do the math.
How does it work?
Well, if an equation is formatted as x squared minus a number plus a number equals 0, both of its roots will be positive. But if it's x squared plus a number equals 0, both roots will be negative.
Okay, so let's apply this weather report to question 44. The x equation is x squared plus 11x plus 30 equals 0. The y equation is y squared plus 3y plus 2 equals 0.
Right, so both are plus-plus equations. That means all roots for x and y will be negative.
Got it.
The roots for x happen to be -5 and -6. The roots for y are -1 and -2.
And since -5 and -6 are further left on the number line, every possible value of x is strictly less than every value of y. You can see the relationship immediately.
Exactly. No deep calculating needed.
But what happens when the weather is identical? Like in question 41, both equations have the minus-plus structure, so all roots are positive. X is 3 or 5, and y is 4 or 5.
This introduces the concept of overlapping roots.
Overlapping roots.
Yeah, so x can be 3, which is smaller than y's 4 or 5, but x can also be 5, which is greater than y's 4 and equal to y's 5.
Oh, I see.
Because x could be smaller, greater, or equal depending on which specific roots you pair up, the relationship fractures. The answer has to be no relation can be established.
Okay, so the strategy is check the signs first. If the signs don't give you a definitive, strictly greater or lesser relationship, then you quickly factor.
That's the way to do it.
Like in question 42, where x is 4 or 7 and y is 7 or 8, since x maxes out at 7 and y starts at 7, x is less than or equal to y.
Spot on. And for question 43, where x is 9 or 10 and y is 5, 8, x is strictly greater.
It's all about comparing the ranges.
Exactly. And occasionally they throw in a perfect square just to test your recognition, like in question 45.
Oh yeah, the x equation is x squared minus 14x plus 49.
Right. That's just x minus 7 squared. So x only has one root, 7. The y roots are 5 and 7, meaning x is always greater than or equal to y.
Okay. Moving from algebra to number sequences, questions 46 through 50 ask us to find the missing number in a series. I always liken number series to trying to identify the rhythm in a song.
That's a good way to look at it.
You're waiting for the beat to drop so you know how to dance to it, but sometimes the rhythm just isn't obvious.
And when you can't hear the rhythm immediately, the best thing you can do is look at the space between the notes. Find the mathematical differences between the numbers.
I call that writing out the differences the skeleton key to unlocking these puzzles. Let's test your skeleton key on question 46 first. The series is 5, 11, 24, 51, 106.
Okay, so if you look at the operations here, it's multiplying by 2 and adding an increasing integer.
So 5 times 2 is 10, plus 1 is 11. Then 11 times 2 is 22, plus 2 is 24.
Exactly. So following that, 106 times 2 is 212, plus 5 gives you 217.
Nice. Okay, what about question 48? The series is 2, 3, 11, 38, 102.
Now, on the surface, that just looks like noise. But if we write out the gaps between those numbers, we get 1, 8, 27, and 64.
Which are perfect cubes.
1 cubed, 2 cubed, 3 cubed, 4 cubed.
Precisely. Once the skeleton key exposes that underlying structure, you know the next gap must be 5 cubed, which is 125. Add that to 102, and the missing number is 227. It's incredibly satisfying. What about when the numbers are shrinking rapidly, like in question 49, 720, 720, 360, 120, 30?
So rapid shrinking always implies division, or fractional multiplication. Here, the rhythm is dividing by 1, then dividing by 2, then 3, then 4.
So the next logical step is dividing 30 by 5, giving us 6.
Exactly.
But I've noticed a trap in questions 47 and 50. Question 50 is just 11, 13, 17, 19, 23. And question 47 is 4, 6, 10, 14, 22, 26. Why do test makers love these specific numbers so much?
Because they are prime numbers.
Primes, of course.
Yeah, question 50 is just consecutive primes, making the next one 29. And question 47 is just consecutive primes doubled.
So 17 times 2 is 34.
Exactly. Test makers love primes because they resist standard mathematical operations. They don't have a clean multiplier pattern or a consistent gap.
They rely entirely on your ability to just recognize them on sight.
Exactly. You just have to know them.
Which brings us perfectly into questions 51 through 55. The art of simplification and approximation. We've been talking about recognizing patterns on sight, and this section tests your mental math under pressure.
Big time.
I know this is a race against the clock, but why not just calculate everything out precisely?
Because that is the ultimate time trap. The exam is testing your judgment just as much as your math.
Interesting.
Honestly, one of the most compassionate things you can do for your future test-taking self is to memorize your squares up to 40 and your cubes up to 20.
Do I really need to? Is it that important?
Let's look at question 55, the square root of 3136 plus the square root of 1764. If you don't know your squares, you are doing manual root extraction, which, that takes minutes.
Yeah, that sounds painful.
But if you have them memorized, you instantly know it's 56 plus 42, which equals 98. It becomes a 5-second problem.
I see. It's the same logic for question 52 then. 36 squared divided by 48 multiplied by 5.
Right.
So if you know 36 squared is 1296, you can quickly simplify the division to 27, multiply by 5, and get 135.
Right. And you also have to embrace the art of chunking. Like in question 51, you need 55% of 720 plus 45% of 340. Don't multiply.
So chunk it again.
Yeah, find 50% of 720, which is 360, and add the remaining 5%, which is 36. That's 396.
Okay, and do the same for the second part. So 50% of 340 is 1 at 70 minus 5%, which is 17, to get a 553. Add them up for 549.
You got it. And question 53 relies on recognizing clean fractions. 5/6 of 1080 minus 7/9 of 720.
Okay, 1080 divides perfectly by 6 to give 180 times 5 is 900. 720 divides by 9 to give 80 times 7 is 560. 900 minus 560 is 340.
Fast and clean. But the real psychological test is question 54. It asks for 15.98 squared plus 29.97% of 449.98.
Seeing those decimals just makes me want to reach for a calculator that I don't have.
That's the trap. The test explicitly labels this as approximation. They want to see if you have the confidence to ignore the noise.
They're just around them.
Exactly. 15.98 is just 16. 29.97% is 30%. 449.98 is 450.
Oh, wow. So you treat it as 16 squared plus 30% of 450. 256 plus 135 equals 391.
Yep. Which easily points you to the closest answer choice of 390.
Confidence to ignore the noise. I love that. Now, for the final stretch, we have reached segment 5. Questions 56 through 65. These are arithmetic word problems.
The grand finale.
I think of these as mini mysteries. The math is just, hiding behind everyday English sentences.
And our goal is to uncover the underlying logical framework for each scenario quickly.
Right. So let's group these mysteries. First, we have the financial mysteries, questions 56 and 61. Question 56 says a sum amounts to 9,920 rupees in 3 years at 8% simple interest. What is the trick here?
Okay, don't get bogged down in the traditional simple interest formula. Think conceptually.
Conceptual, okay.
8% a year for 3 years is 24% total interest. That means the final amount is 124% of the original sum.
So 9,920 divided by 1.24 gives you the original 8,000 rupees.
Exactly. Beautifully conceptual.
And question 61 is similar. An article is sold for 5,380 rupees at a 15% profit.
So finding the cost price just means recognizing that 1,380 is 115% of the original cost.
Divide by 1.15, and the cost was 1,200. Okay, next up are the physical world mysteries. time, work, and distance in questions 57 and 58.
For question 57, A is twice as efficient as B, and together they finish a job in 12 days. The framework here is assigning units of work.
So if B does 1 unit a day, A does 2.
Right. Together they do 3 units a day. In 12 days, they finish 36 units.
And if A works alone, doing 2 units a day, 36 divided by 2 means A takes 18 days.
You've got it.
Nice. And for question 58, a 150-meter train running at 54 kilometers per hour crosses a stationary pole. The trap here is the mixed units, right?
Exactly. You must convert kilometers per hour to meters per second.
So 54 kilometers per hour is 15 meters per second.
Right. And since the pole has no length, the train just has to clear its own 150 meters. 150 divided by 15 equals 10 seconds.
Let's move to the ratio mysteries, questions 59 and 60. Question 59 involves 60 liters of pure milk. 12 liters are removed and replaced with water.
This sounds complex, but just follow the physical volumes. You remove 12 liters of milk, leaving 48 liters.
Then you put in 12 liters of water.
Yeah, exactly. So your final ratio is just 48 to 12. Divide both by 12, and you get a clean 4-to-1 ratio.
So straightforward. And question 60 is basic probability. Tossing 2 fair coins, what is the chance of getting exactly 1 head?
Well, out of 4 total outcomes, heads, 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 tails, tails, heads, tails, tails, only heads, tails, and tails, heads fit the criteria.
That's 2 out of 4, or a 1 in 2 chance.
Yep, 1 or 2.
Okay, finally, let's hit the abstract logic puzzles, questions 62 through 65. Question 62 is a classic age problem. Mother and daughter total 50 years now. 5 years ago, the mother was 7 times as old. How do we crack this without a massive algebraic mess?
By shifting the timeline, if they total 50 today, what did they total 5 years ago?
Well, they both get 5 years younger, so you subtract 10, they totaled 40.
Correct. And back then, the ratio was 7-to-1, meaning 8 parts total.
So 40 divided by 8 parts means 1 part equals 5 years. So the daughter was 5, the mother was 35.
Right, and then bring the mother back to the present day by adding 5, and she is 40.
Oh, this next one, question 63, is highly practical. The price of sugar rises by 25%. By what percent must the family cut its consumption so their spending stays exactly the same?
This is a beautiful lesson in inverse economics. The new price is 125% of the old price.
Right.
To maintain equilibrium, the family can only consume 100 parts out of that new 125. 100 over 125 simplifies to 4/5.
If you're consuming 4/5 of what you used to, you have cut 1/5, and 1/5 is 20%.
Exactly.
That is genuinely useful for budgeting. Wrapping up, question 64 asks for the volume of a cube with a surface area of 294.
So since surface area is 6 times the side squared, 294 divided by 6 means the side squared is 49.
The side is 7. Volume is 7 cubed, or 343. And final question 65. The average of 5 consecutive even numbers is 34. Find the largest.
What's fascinating here is a fundamental, almost magical rule of averages. For any odd number of consecutive evenly spaced integers, the average is always the dead center number.
Wait, really? You don't need algebra.
No algebra needed. The middle number is 34. Counting up by evens, the next is 36, and the largest is 38.
Wow. And just like that, you have navigated the entire forest. You made it through all 35 quantitative aptitude questions.
It's a journey.
Look how much ground you just covered. From decoding data pantries to recognizing prime number rhythms to solving everyday mysteries of train speeds and sugar budgets. You didn't get lost in the weeds. You saw the underlying mechanisms.
And if we connect this to the bigger picture, practicing quantitative aptitude isn't just about passing a preliminary exam for a bank probationary officer role. It is literally rewiring your brain.
Rewiring it how?
Well, when you learn to approach these abstract problems methodically, when you learn to spot the traps and ignore the noise, you start to see the world with a sharper, more analytical lens.
So what does this all mean for you outside the exam hall?
It means you start seeing the hidden equations in everyday life. When you read new statistics, when you weigh financial decisions, or even assess daily risks, your brain is quietly calculating probability, averages, and inverse ratios. You become a more informed, logical participant in the world. You aren't easily fooled.
I love that thought. So the next time you are staring at what feels like a wild, untamed forest of data, whether on a standardized exam or in your daily life, remember today, you have the tools to see the rose. You know how to read the weather before the storm? Keep practicing. Be kind to your future test-taking self by learning those squares, and we will see you on the next deep dive.
You know that feeling when you first look at a massive reasoning exam?
Oh, the wall of text.
Yeah, exactly. You're just staring at a screen. There's this literal wall of text, a dozen conflicting rules, and your brain is just, expected to work like a supercomputer.
Right, and it feels incredibly binary in that moment. Like, you either see the hidden pattern immediately or you're just staring at a blank page while the clock ticks down. It's totally overwhelming.
It is terrifying. But then, you take a breath, you step back, and you realize that every single one of these massive, intimidating puzzles is actually it's just a series of tiny, manageable clues stacked on top of each other.
I mean, it is the absolute definition of building a foundation. You don't build a house by dropping a fully formed roof onto an empty lot, right?
Right, definitely.
You lay one single undeniable brick at a time.
That is exactly what we are doing today. Welcome to this custom deep dive. If you are listening to this right now, you are on a very specific, very important mission. You are conquering Section 3, Reasoning Ability, of the IBPS CRP POMT 2026 Model Paper 05.
That's right.
And we are taking the 35 most intimidating hurdles from this exam, specifically questions 66 through 100, and we're just going to dismantle them one by one.
And we're going to do it methodically, calmly, and sequentially. If you're prepping for this exam right now, this session is really just about giving your brain the space to absorb the logic. No rushing.
We're going to build your reasoning muscle today. So we'll start with spatial puzzles, like organizing people in buildings and by height.
Always a good warm-up.
Yeah. From there, we'll move into how the exam strips away the physical world and asks you to organize abstract numbers and logical statements. Then we'll decode some inequalities, build a family tree, and finish strong with spatial mapping and sequences.
It's a perfect workout, honestly. Let's jump right into organizing physical space. This is a classic floor and flat puzzle covering questions 66 through 70.
Okay, here is the setup they give us. We have a building with 3 floors. Floor 1 is at the bottom, floor 3 is at the top. Simple enough. Each floor has 2 flats, flat 1 and flat 2. There are 6 residents, A, B, C, D, E, and F. The rules state, okay, here we go. D lives in flat 1 of the lowest floor. A lives immediately above D in the same flat.
Right.
E lives immediately above A. We are also told B and E live on the same floor. Finally, C lives below F, and both of them live in flat 2.
So when you have a blank grid on your scratch pad, just, 6 empty boxes, it is very easy to get lost in all the moving parts. But this is where you look for your anchor.
The undeniable truth.
Exactly. What is the one undeniable truth? Let's look at flat 1. We know exactly who lives there because the rules literally stack them right on top of each other.
Yeah, it explicitly says D is on floor 1, flat 1. That's our anchor.
And A is right above D, placing A on floor 2, flat 1.
Okay.
E is right above A, placing E on floor 3, flat 1. Just like that, flat 1 is completely solved.
Half the puzzle is just done. It really is like solving a Sudoku puzzle. You don't look at the whole blank board and panic. You just find that one number they gave you and build out from there.
Precisely. Now we just look at flat 2. The clues say B and E share a floor.
Right, and we just placed E on floor 3.
Exactly. So B absolutely must be right next door in flat 2 of floor 3. That leaves us with only floor 1 and floor 2 open in flat 2. We're told C lives below F, and both are in flat 2.
So F takes the higher one.
Yep. F takes floor 2 and C takes floor 1. Our grid is full.
And once your grid is built, the next 5 questions on the exam just answer themselves. You don't even have to think anymore. For question 66, they ask who lives in flat 2 of the topmost floor. You just look at your map and it's clearly B.
Same for question 67. Who lives immediately below F? Well, F is in flat 2 of floor 2. The person right below them in flat 2 is C.
Question 68 wants to know who is on the same floor as D. We anchored D on floor 1, flat 1, so the only other person on the ground floor is sitting right next door in flat 2, which is C.
Then they try to trick you with question 69 by asking how many persons live between E and D in flat 1.
Oh, that sounds complex.
It does, but D is on the bottom, E is on the top. The only person sandwiched between them is A. So the answer is exactly one person.
And to wrap up that puzzle, question 70 asks for the pair of persons living on the middle floor. The middle floor is floor 2. Looking at our grid, we have A in flat 1 and F in flat 2. So the pair is A and F. That wasn't bad at all.
Not at all. You just have to trust the process.
Yeah.
Let's keep that momentum and stay with organizing physical traits for questions 71 through 75. This is a height comparison puzzle.
Okay.
We have 6 people, P, Q, R, S, T, and U. The clues give us 2 specific numbers to anchor to. The second tallest is 178 centimeters, and the third shortest is 160 centimeters.
And the relational clues they give are, only 2 persons are taller than Q. T is taller than Q but shorter than S. P is taller than only U. And R is shorter than Q.
Let's break this down patiently. When the exam uses the word only, pay close attention. Only 2 persons are taller than Q. Means Q is sitting exactly in the 3rd position from the top. No more, no less.
Right.
Next, T is taller than Q, but shorter than S. That neatly gives us our top three right away. S is the tallest, T is second, and Q is third.
The word only is doing a lot of heavy lifting in the next clue too, isn't it? P is taller than only you.
Incredibly heavy lifting. If P is taller than only one single person in the whole group, P has to be the second shortest.
Yeah.
And U must be the absolute shortest person overall.
Leaving just R to fill the remaining empty slot, which is fourth from the top. So our final order from tallest to shortest is S, T, Q, R, P, U. But before we get to the answers, I just have to ask on behalf of anyone studying for this exam.
Sure, what is it?
When an exam gives you specific heights, like 178 centimeters and 160 centimeters, my brain immediately wants to start doing math. Am I supposed to be calculating exact gaps between these people?
I am so glad you brought that up. That is such a crucial question, and the answer is an absolute no. That is a time trap.
Really? A time trap?
Yes. This is purely about establishing numerical ranges. Don't waste precious seconds on heavy math. T is second tallest, so T's placeholder is 178. R is third shortest, which we know is fourth from the top. So R's placeholder is 160. That's all the math you need.
Good to know. So when question 71 asks who the tallest is, we already know it's S. And for question 72, the third tallest is Q.
For question 73, they ask how many persons are shorter than R. Looking at our lineup, S, T, Q, R, P, U, only P and U are behind R, so the answer is 2.
Now here is where those number placeholders come in for question 74. Which of the following can be the height of Q? Well, Q is sandwiched right between T and R.
Exactly.
We know T is 178 and R is 160, so Q's height just has to fall somewhere between those two numbers. If you look at the multiple choice options, 170 centimeters is the only choice that fits that range.
See, you didn't need to calculate a thing, just logic. They do the same thing for question 75. If P's height is 157 centimeters, what could be the height of U?
Well, we established U is the absolute shortest, meaning U must be strictly less than P's 157. The only option provided on the test that is less than 157 is 152 centimeters.
Perfectly done.
Now that we've mastered organizing physical spaces and heights, let's see what happens when the exam strips away the physical world. Let's pivot to pure abstract rules for questions 76 through 80.
The machine input-output problem.
Yeah, these can feel incredibly daunting because they just throw a string of numbers at you. The input line is 48, 25, 73, 16, 91, 34. The machine rearranges them step by step.
And the rule is that step I moves the largest number to the leftmost position, step 2 moves the smallest number to the rightmost position, and it just alternates this pattern, largest to left, smallest to right, until the whole line is in perfect ascending order.
Right, so if you are listening to this on a walk or a commute right now, please do not try to hold all 6 of these random numbers in your head. What matters here is the visual pattern. It's exactly like organizing a messy bookshelf.
That is the perfect analogy.
So step I, you scan the shelf, pull the absolute tallest book, which is 91, and slide it to the far left. Step 2, you look at what's left, find the shortest, tiniest paperback book, which is 16, and tuck it away on the far right.
Right, and on test day, do not rewrite the entire string of numbers for every single step.
Oh, yeah, that eats your clock.
It really does. Just write the original line once and use little arrows or cross out the numbers as you move them mentally. So for step 3, we go back to the left side. What's the largest of the remaining unsorted books? It's 73. So we pull it to the left, tucking it just past our 91.
Okay, got it.
Step 4, we need the smallest remaining number to move to the right. Between 48, 25, and 34, the smallest is 25. We tuck it to the right, just before the 16.
And if you look at the line at that point, so it's 91, 73, 48, 34, 25, 16, the entire shelf is in descending order. The machine stops.
And those steps give you everything you need. Question 76 asks for the exact sequence in step 2, which we found by pulling 91 left and 16 right.
Right, and question 77 asked for the position of 25 in step 3. If you mapped it, 25 is sitting exactly fourth from the left.
Question 78 asks how many total steps were required. We hit perfect order at step 3, so it takes exactly 4 steps.
For question 79, they want to know which number is third from the right in the final arrangement. So counting backward from the right side, 16, 25, 34, the third number is 34.
And for question 80, they ask a specific detail about step 4. What is the sum of the second and fifth numbers from the left? In step 1, our line was 91, 48, 25, 73, 16, 34. The second number is 48, the fifth is 16. Add them together, and you get 64.
Moving right along to questions 81 through 84, we are tackling syllogisms. I feel like syllogisms notoriously trip everyone up because they use normal words in completely illogical ways.
Oh, absolutely.
But if you just draw quick mental Venn diagram circles, it instantly becomes manageable. We're looking for absolute truths versus possibilities.
Exactly. Let's look at question 81. Statements: all cups are mugs, no mug is a jar.
Okay, so picture the cup circle completely trapped inside a bigger mug circle, and that mug circle is drawn light years away from the jar circle. They can never touch.
Precisely. So when conclusion I says some jars are cups, it is completely false.
Right.
The jars can't even touch the outer boundary of the mugs, let alone reach the cups trapped inside.
Right.
But conclusion 2 says no cup is a jar. That is a solid, absolute truth based on our drawing. So only conclusion 2 follows.
Okay, but question 82 looks like a massive trap. Statements: some pens are inks, all inks are colors. Conclusion I says all pens are colors. Conclusion 2 says some pens are not colors. Wait, if some pens are inks and all inks are colors, my brain immediately wants to assume all pens are colors. Why is that a trap?
It is a brilliant trap by the exam writers. This brings up an incredibly important rule. Only the specific pens that overlap into the ink circle are guaranteed to be colors. But what about the rest of the pen circle hanging out on its own?
Oh, right. We don't know anything about them.
Exactly. They might be colors or they might not be. The exam didn't tell us. So neither conclusion is a proven certainty on its own.
Ah. So we can't definitively say they all are, and we can't definitively say they aren't.
Right. However, look at the language. Conclusion I claims they all are. Conclusion 2 claims some are not. In the reality of the universe, one of those two opposing states absolutely must be true. They form what we call a complementary pair. So the correct exam answer here is either I or 2 follows.
That is such a vital tip. Okay, question 83. Statements: some shirts are coats, all coats are jackets. Conclusion 1, some shirts are jackets. Conclusion 2, some jackets are coats.
This one is more straightforward. If all coats are trapped inside jackets and some shirts overlap with the coats, then those shirts are automatically touching the jackets too. Conclusion I follows perfectly.
Makes sense.
Furthermore, if all coats are jackets, it naturally means that at least some of the overall jacket category is made up of coats. So conclusion 2 also follows. Both follow.
And question 84. Statements: no cat is a dog, all dogs are foxes. Conclusion 1, some foxes are not cats. Conclusion 2, all foxes are dogs.
Picture the dog circle completely inside the fox circle. Now remember the strict rule. No cat is a dog. This means those specific foxes that happen to be dogs can never ever be cats. Therefore, conclusion I, some foxes are not cats, follows as an absolute truth.
Oh, wow. Yeah.
However, conclusion 2 fails because there is nothing in the statements to prove that every single fox is a dog. The fox circle might be huge, so only I follows.
It's like unlocking a code, which is the perfect transition because for questions 85 to 87, we are literally deciphering coded inequalities. They are swapping mathematical symbols for punctuation marks.
The setup here translates symbols into math signs. Percentage means greater than or equal to. Exclamation mark means strictly greater than. Caret means strictly less than. Asterisk means less than or equal to. Tilde means equal to.
So, question 85 statements translate to: D is greater than E is greater than or equal to F, and F is equal to G. Conclusion I says D is greater than F. Conclusion 2 says G is less than E.
Think of these inequalities like a stream of water.
A stream of water?
Yeah, if the arrows all point in the same direction, the logic flows smoothly. Look at the change from D. F. D is strictly greater than E, which is greater than or equal to F. The greater than momentum holds strong across the whole chain, so D is definitely greater than F. Conclusion I follows.
But what about conclusion 2?
For conclusion 2, we know E is greater than or equal to G. Because they could be exactly equal, we cannot definitively claim that G is strictly less than E. It might be, but it's not guaranteed, so only I follows.
Got it. Okay, question 86 statements. J is less than or equal to K is less than L, and L is greater than or equal to M. Conclusion I, J is greater than L. Conclusion 2, M is greater than or equal to L.
Here is where you have to spot the broken chain. Look at the signs clustered around L. You have K is strictly less than L, but then instantly L is greater than or equal to M. The arrows point toward each other. They clash.
Oh, I see.
This breaks the chain of logic completely between the left side and the right side of L. You can't draw conclusions across a broken chain. Furthermore, J is clearly less than L based on the first part, making conclusion I outright false. And we only know L is greater than or equal to M, making conclusion 2's claim reversed and uncertain. Neither I nor 2 follows.
Question 87 statements. R is greater than or equal to S is greater than T is less than or equal to U. Conclusion I is greater than T. Conclusion 2, U is greater than or equal to T.
The chain flowing from R to T is, well, R is greater than or equal to S, which is strictly greater than T. The water flows smoothly. R is greater than T is a certainty. Conclusion I follows.
And conclusion 2.
For conclusion 2, the statement directly gives us T is less than or equal to U. If you just read that backward, it's exactly the same as saying U is greater than or equal to T. So conclusion 2 also follows. Both are true.
Let's stick with relationships but switch to human ones. Questions 88 through 90 ask us to map out blood relations. We have a family of 6, A, B, C, D, E, and F. A quick tip for you listening. When you are on the exam, use a simple shorthand on your scratch pad for family trees. A little plus sign next to a letter for male, a minus sign for female. It stops you from getting completely lost in the generations.
That is great advice. Let's build the tree. The statements tell us B is married to A. They are the parents, but we don't know their genders yet. They have 2 children, D and C. We are told C is the sister of D, so C gets a minus sign for female.
Makes sense.
Next, E is married to D. And finally, F is the son of D and E, giving F a plus sign.
Once that simple tree is drawn, the questions are rapid fire. Question 88. How is C related to F?
We know F is the son of D. We know C is the sister of D. The sister of someone's parent is their aunt. So C is the aunt of F.
Question 89. How is A related to E?
A is a parent to D. E is married to D. The parent of your spouse is your mother-in-law or father-in-law. Since the provided options list mother-in-law, and based on the source material's correct answers, we accept A as the mother-in-law to E.
Question 90. How is F related to B?
B is the grandparent level. B is the parent of D. F is the son of D. The son of your child is your grandson. F is the grandson of B.
We are entering the final sprint. Questions 91 to 100 cover navigating space and sequences. We take everything we've practiced today and apply it to maps, ranks, and codes. Let's start with direction sense. Question 91. Sonal walks 7 kilometers east, turns right to walk 3 kilometers south, turns right again to walk 7 kilometers west, and finally turns left to walk 2 kilometers south. How far and in which direction is she from the start?
Don't let the twisting directions confuse you. Map the axis. She went 7 clicks east and then later went 7 clicks west. Those opposite directions completely cancel each other out. Her east-west displacement is 0.
Right, but on the north-south axis, she walked 3 kilometers south and then another 2 kilometers south. Add those together, and she is exactly 5 kilometers south of where she began.
Exactly. Question 92 is purely relational. Point A is north of B. Point C is east of B. Point D is south of C. In which direction is D from B?
Well, visualize B right in the center of a compass. C is to the right, east. D is directly below C, pointing south. Since D is both shifted to the east and shifted to the south relative to that center point B, D is firmly to the southeast of B.
Question 93 introduces a slight angle. A man drives 4 kilometers north and then 3 kilometers east. What is the minimum distance to return straight to his start, and in which direction must he go?
Oh, my math brain loves this one. If you connect his final location straight back to his start point, you just drew a right-angled triangle with legs of 4 and 3. That is the classic Pythagorean triple. 3, 4, 5.
It sure is. The direct return distance is the hypotenuse, which is the square root of 16 plus 9, equaling exactly 5 kilometers. And since he currently sits north and east of his origin, he must travel south and west to get home. So the answer is 5 kilometers southwest.
Questions 94 through 96 pivot to dictionary order. We are given 5 numbered words. 1 is garment, 2 is garden, 3 is garlic, 4 is garage, 5 is garnish. We have to alphabetize them. Now, I always just scan the first letter, see they are the same, and start to panic.
That's completely normal, but you have to actively ignore the GAR chunk because every single word shares it. Skip straight to the 4th letter.
Right.
The distinguishing 4th letters are M for garment, D for garden, L for garlic, A for garage, and N for garnish.
Ah, okay. Alphabetizing just those letters, A, D, L, M, N, gives us our new order. Garage, garden, garment, garnish.
And then you just read down the new list. Question 94 asks which word comes third. That's garlic. Question 95 asks which word comes last. The last one is garnish.
Question 96 asks a meta question. How many of the words remain at the same numbered position when rearranged? The original order was garment, garden, garlic, garage, garnish. Our new order is garage, garden, garlic, garment, garnish.
Let's compare them.
Garden is second in both. Garlic is third in both. Garnish is fifth in both. So exactly 3 words keep their original positions.
Moving to order and ranking for questions 97 and 98. Question 97. Mohan is 12th from the left. He swaps seats with someone who is 18th from the right. After the swap, Mohan is now sitting in the 20th position from the left. How many persons are in the row?
I always try to draw like 30 little stick figures on my paper for these, which takes forever.
Do not draw stick figures. There is a golden mathematical formula for this. Total equals left position plus right position minus 1.
Wait, really? Just a formula?
Yep. After the swap, Mohan is sitting in a physical chair that we know is 20th from the left, and we know that exact same chair used to be 18th from the right. So 20 plus 18 is 38. Minus 1 gives us 37 total persons.
And the reason we minus 1 is just because if you add the left count and the right count, you accidentally counted Mohan's specific chair twice.
Exactly.
Yeah.
You subtract 1 to remove the duplicate chair.
Yeah.
And you use a variation of that exact same formula for question 98. A class has 45 students. Rena's rank from the top is 18th. What is her rank from the bottom?
So rank from the bottom equals the total, minus the rank from the top plus 1. 45 minus 18 is 27. Add 1, and you get her rank as 28th from the bottom.
Beautifully done. 2 questions left. Question 99 is coding decoding. The word table is written in a secret code as FMCBU. How is the word chair written in that same code?
I'm looking at T becoming F, which is a huge jump backward in the alphabet, but A to M is a huge jump forward.
Don't look at it straight on.
Okay.
The trick here is twofold. First, reverse the whole word table backward to get LBAT.
Okay, E-L-B-A-T.
Then shift every single letter just one step forward in the alphabet. E becomes F, L becomes M, B becomes C, A becomes B, T becomes U. That gives you FMCBU.
That is devious. Okay, so apply that to chair. Reverse it to R-I-A-H-C. Shift every letter plus 1. R becomes S. I becomes J. A becomes B. H becomes I. C becomes D. The answer is S-J-B-I-D.
And finally, question 100. A number sequence test. We have a string of numbers, 5, 3, 5, 5, 7, 5, 8, 5, 5, 9. The question asks, how many 5s are immediately preceded by another 5?
The danger here is just glazing over. You have to literally trace it with your finger or your pen tip on the screen or paper. Scanning the sequence, let's see, I see a 5 following a 5 at the 4th digit, and then again near the end at the 9th digit. That's exactly 2 instances. A nice, calm, easy win to finish the entire section.
It is always good to end on a straightforward note.
If you've been listening and following along today, massive congratulations to you. Think about what you just accomplished. You just conquered 35 dense, complex reasoning questions.
That's a huge deal.
You moved from spatial logic and floor flats to finding absolute truths and syllogisms. You decoded mathematical inequalities, built a family tree out of thin air, and navigated maps and word codes. You are incredibly capable of handling this exam.
If we connect everything we did today back to the bigger picture, I want to leave you with one final, empowering thought to ponder. Notice how every single complex reasoning puzzle we solved today wasn't actually a giant, impossible wall. It was just a series of tiny, simple, undeniable truths stacked on top of each other.
Yeah, that's so true.
The next time you sit down and see an overwhelming logic puzzle on the exam, take a breath and ask yourself, what is the one undeniable truth I can anchor to right now?
Like finding D on floor 1, flat 1.
Exactly. Find that anchor, put it down on your scratch pad, and the rest of the puzzle will naturally build itself around it.
That is the absolute perfect way to look at it. Thank you for joining us on this deep dive into the reasoning section. Keep practicing, be kind to yourself when you get stuck, and remember that consistency is your greatest weapon. You've got this. What's your anchor going to be tomorrow?